In a scientific test built specifically to measure forethought, the ability to plan for a future you can't currently see, ravens didn't just pass, they beat 4-year-old children. By the end of this video, you'll know how a brain with no cortex at all, nothing like ours, structured completely differently, ends up matching a chimpanzee. You'll see the exact experiment where ravens planned further ahead than young kids. You'll learn how a raven can act as if it's being watched, even when it can't see or hear anyone else in the room. You'll find out why messing with a raven is a bad idea for at least a month, maybe longer. And stick to the end, because the way ravens actually get fed involves gangs, informants, and an alliance with wolves that sounds made up but isn't. Start with the hardware, because it explains everything else. A raven's brain is tiny compared to yours, a few grams, easily fits in your palm, but it's built on a completely different plan. Bird brains pack in roughly twice as many neurons as a mammal brain of the same size. And in the region that does the heavy lifting for decision-making, ravens pack in 3 to 4 times the neuron density you'd find in the equivalent part of a primate brain. No cortex, no folds, just density. What that buys them is startling self-control. In one classic test, a piece of food sits inside a clear tube, open at both ends. The obvious move is to go straight for it, straight into the glass. Ravens learn to stop, walk around, and reach in from the side. The same result chimpanzees get on the exact same test. That's not instinct. That's a bird overriding its own impulse in real time. They also build and use tools from raw material, twigs bent into hooks, stones and pine cones repurposed for a specific job. And researchers have logged at least 11 distinct ways ravens put objects to work as tools. And when a young raven is handed a genuinely novel problem, a multi-step puzzle it's never seen before, some adult ravens have solved it in under 30 seconds on the first try, with no trial and error at all. That's not luck, that's working the problem out in its head before it moves. This is the one that changed how scientists think about animal minds entirely. Researchers taught ravens a skill they don't use in the wild, picking up a specific stone and using it to knock a piece of food out of a puzzle box. Once they learned it, the scientists took the box away completely. An hour later, they showed each raven 4 objects, the correct stone, and 3 decoys that were too light or the wrong shape to work. No box in sight, no reward waiting, just a choice. 15 minutes after that choice, the box came back. The ravens that had picked the correct stone used it successfully to get their food the vast majority of the time. They weren't reacting to something in front of them. They were holding on to a tool for a problem that, as far as they could see in that moment, didn't even exist yet. Then the researchers pushed further. They taught the ravens to trade a small token for an even better reward later. And here's the part that matters. They tested it with a smaller, easier reward sitting right there, available immediately, no waiting required. Take the easy one now, or hold out and trade later for something better over and over. The ravens held out. When scientists ran the numbers, ravens outperformed 4-year-old children tested in a comparable setup and matched or beat great apes on the same task. Now, worth being honest here, some researchers argue this doesn't prove ravens experience the future the way we imagine it in our own heads. It might be an extremely sophisticated form of learned association rather than true imagination. Nobody can fully settle that yet. But by every behavior anyone can actually measure, these birds ravens hide food constantly. Thousands of caches scattered and remembered individually. And the moment another raven might be watching, everything about how they hide it changes. If a rival is nearby, a raven will cache in a spot that's harder to see, move faster, or even fake a cache, going through the motion of hiding food without actually leaving any there, before sneaking off to hide the real thing somewhere else once no one's looking. They also treat rivals differently, depending on what that rival actually knows. A raven that watched the food get hidden gets treated as a real threat. One that clearly didn't see anything gets ignored. Here's the detail that made researchers sit up, though. In one experiment, ravens were caching food near a small window others could look through, except in some trials, that window was blocked and there was no other raven anywhere nearby to see them at all. Even then, hearing another raven's presence on the far side of a wall was enough to make them cache more cautiously, as if they were reasoning someone could be watching me right now, without any direct evidence that anyone actually was. That's a level of imagining another mind that almost nothing outside of great apes and humans has clearly demonstrated. Ravens keep score, and they keep it for a long time. In one study, researchers set up simple trades with captive ravens. Some trainers always gave a fair exchange. Some consistently cheated them out of a better reward. It only took one bad trade. Weeks later, in a follow-up test, the ravens that had been cheated went out of their way to avoid that specific person while still approaching the ones who traded fairly. Researchers believe that memory can last considerably longer, potentially as long as ravens remember individual cage mates, which can stretch to roughly 2 years. That memory runs both directions too. Ravens build what researchers call social capital. Favors like preening or backup during a scuffle with another bird go selectively to individuals who've been reliable in the past. It's a functioning reputation economy, running entirely on memory of individual past behavior. In the wild, this is exactly the kind of tracking that lets a raven decide in a split second which neighbor to trust and which one to watch closely. Here's where all of this intelligence actually pays off in how ravens get fed. A mated pair holds a territory for life, sometimes for decades, and they'll defend a carcass inside it fiercely against almost anything. A young, unpaired raven, and ravens don't pair off until they're a few years old, doesn't hold territory at all. Instead, unpaired juveniles gather at shared overnight roosts that function almost like a bulletin board. A juvenile who finds a carcass guarded by a territorial pair flies back to the roost and starts yelling. Loud, distinctive calls. Recruiting other juveniles it isn't even related to. The next day, a whole crowd shows up, sometimes needing half a dozen or more birds before a defending pair finally gives up and allows the group to feed. It looks generous. It isn't, really. A lone juvenile can't beat 2 defending adults. A gang of juveniles can. Recruiting help is the only way any of them gets to eat that carcass at all, which is a strategy built entirely on the fact that a raven can predict how a rival will behave and plan its own move accordingly. And then there's the strangest partnership of all. A raven's beak isn't strong enough to tear open the tough hide of something like a moose or an elk. So in the wild, ravens have been documented calling in wolves that are perfectly capable of ripping a carcass open and simply waiting nearby. The wolves feed, the ravens clean up what's left. Neither species planned this relationship in any deliberate sense, but it's stable and repeated enough across generations that biologists sometimes just call ravens wolf birds.
None of this is one flashy trick. It's 5 completely different cognitive systems: self-control, forward planning, reading what a rival can and can't see yet, tracking reputations over months, and coordinating group strategy, all running at a high level at the same time inside a brain that shares almost no structural resemblance to yours. Intelligence like this evolved independently in birds and in apes, on separate branches of the tree of life, arriving at strikingly similar results by 2 completely different roads. That's not a fluke. It's what happens when a highly social species has to remember exactly who to trust, plan for food it can't see yet, and outmaneuver rivals it can't outmuscle.
So the next time a raven watches you a little too closely from a fence post, consider the possibility that it's actually doing exactly that: watching, remembering, and deciding whether you're worth trusting. Next video, we're going somewhere completely different. An animal with 3 hearts, blue blood, and a nervous system so unusual that 2/3 of its neurons aren't even in its brain, they're in its arms. And each arm can solve problems on its own. The octopus. If a bird with no cortex can plan like an ape, wait until you see what a creature with a decentralized brain can do. Subscribe so you don't miss it.